All right, let's run through each of these problems real fast. Shouldn't be too hard. This, when it's dropped, it tells us that our VI is equal to 0. We know the time was the distance. All right, distance is our unknown. So it can be distance / displacement. They both are going in the same direction, so we're not too worried about that. Again, with any free fall problem, we know acceleration is equal to negative 9.8. We have our VI is equal to 0. Our T is equal to 0.3. Our unknowns is displacement. All right, equation. Because we have D, A, VI, and T, we don't have any VF. We're going to have to do delta D is equal to VI times T plus 1/2 A times T squared. Alrighty, let's work through this problem. And you should get a number that I won't tell you, but I just want to kind of show you how to set it up. Plus 1/2 times negative 9.8 times 0.3 squared. All right, that's problem 1. All right, problem 2. He fell 40 meters. So if you fall 40 meters, you know that you're saying the distance, and falling tells us VI is equal to 0. Again, because we're only going in one direction, distance and displacement are the same. I'm rewriting this, but we know A is equal to negative 9.8 because it happens on Earth. How long did it take him to reach the ground? Again, English can be silly, but this is asking for the time. So our unknown this time is time. Our given values are all in the same vein as the other problems. And this is meters per second. All right. Equation. It's the same one. The delta D equals ... So I am going to plug it in. So delta D this time is 40 is equal to, okay, this one, negative 40, because we fell. And I said that A is equal to negative 9.8. So negative 40 is equal to 0 times T plus 1/2 times A, which is negative 9.8, times T squared. All right, those cancel out, and you should be left with 40 is equal to negative 4.9 times T squared. This one, just make sure that when you divide both sides by negative 4.9, whatever your final answer will be, it's a little bit more than 8. Square root of 8 point something is equal to T square root. Cancel those out. The reason I did the square root is I got to get rid of that square. I'm not going to tell you the answer because I want to see that you did it and plug it in. All right. Okay, so before you go through this problem, I hope you already watched the Futurama clip. If you haven't, I recommend it. It's silly, stupid fun, and it's a really, really great animated show that I highly recommend watching if you have the time. So, in order to continue my love for Futurama, I'm going to try to read through this problem as if I were Zap Brannigan. So, I'm going to close this to make it look even more like, imagine, put it in your brain that I'm about to be Zap. All right, you ready? Zap is driving a steakhouse, but gets caught in an unknown planet's gravity. Assuming he starts at rest, what is the acceleration due to gravity if he fell 786.5 meters after 11 seconds? All right, so let's read through this problem. We've seen that starting at rest tells us our VI is equal to 0, and I can't do it anymore. I think it was better than the last time I tried it, but I've redone this a few times, but not that great. So VI is equal to 0. Delta D is equal to 786.5. Since he fell, we're going to say it's negative 786.5 meters. And the time is 11 seconds. My unknown is acceleration due to gravity. That is A is equal to question mark. My equation is our fancy new one. All right. Now, all I got to do is plug it in. So negative 786.5 is equal to 0 times 11 plus 1/2. A is not negative 9.8, so we got to just leave it as A because that's our unknown. And times 11 squared. All right. Negative 786.5 stays the same. 11 squared is 121. So 121 divided by 2 is 60.5. Should be. Yeah, I got it. 786 point. That's really tight. My bad. All right. If you are struggling with room, you can always switch to text and you don't have to draw. There is an option for that. So 60.5 negative 786.5 divided by 60.5 equals negative 13. So I gave you a whole number, so it's a little bit better. So acceleration is negative 13. Okay? So, next problem. How far did he fall if it took 30 seconds to reach the ground? Using this acceleration. So now, we know acceleration is equal to negative 13. We know the new time we're using isn't this one. It's now 30 seconds. Remember, VI was 0 because we're saying the total amount of time it took for him to fall. And the unknown is how far, which is displacement or distance, whatever you want to call it this time, it doesn't matter. All right, equation is the same. This is easier. This is just straight plugging it into that equation up there. And I'm going to leave the rest to you. Hopefully, you're able to follow along with this. If you're stuck on anything, please let me know. And in a way, please make sure that you watch this Futurama clip because Zap Brannigan is an incredible TV character, if I do say so myself. All right. Signing off. Hasta luego. Goodbye. Hasta la vista, baby.